Hey, welcome to World Mind Hub. Please subscribe the channel and press the bell icon for more updates. Today, a tremor shakes the geological community. California's Long Valley Caldera, a supervolcano, is showing renewed signs of life. Scientists have detected deep magma movement beneath the state. Supervolcanoes aren't ordinary. Their eruptions can reshape continents and alter climates. Scientists are working around the clock, analyzing subtle yet undeniable changes. Sensitive instruments pick up tiny tremors and slight ground deformation. Think of it as the Earth taking a slow, deep breath. The scientific community is on high alert but not panicking. This is what they train for. The focus now: continuous monitoring, careful analysis, and clear communication. The story is still unfolding. The Earth's fiery heart stirs, and we are listening. How do we know magma is moving? We look from space. Satellites orbit above, equipped with sensors that detect even the slightest ground changes. If the ground beneath Long Valley swells, satellites measure it, like watching bread rise in the oven. This technique, called INSAR, is a game changer for volcano monitoring. These maps reveal where the Earth has uplifted or subsided, clues that magma is on the move. It's a clear signal. The volcanic system is active, not dormant. The Earth's secrets are coming into focus. To understand today's news, we must look back. About 760,000 years ago, Long Valley Caldera erupted in a super eruption of unimaginable scale. Over 600 cubic kilometers of rock and ash were ejected, enough to blanket California in inches of debris. The Bishop Tuff, remnants of that eruption, can still be found as far as Nebraska. The eruption caused the ground to collapse, forming the vast caldera we see today. 20 miles long, 11 miles wide, thousands of feet deep. The energy released dwarfed any nuclear weapon ever detonated. It reshaped the landscape and altered the climate for years. Since then, Long Valley hasn't been silent. Smaller eruptions, ground uplift, and earthquake swarms have occurred. The most recent activity, 600–700 years ago, formed the Inyo craters and domes. These events prove the magmatic system beneath Long Valley is still alive. The magma chamber that fed the super eruption still exists, partially molten. This history is why scientists pay such close attention to Long Valley. The potential for future eruptions, though likely smaller, is real. Understanding the caldera's past is crucial for interpreting current unrest. The legacy of that ancient eruption is a stark reminder of the forces beneath our feet. It underscores the need for vigilance and scientific inquiry. Long Valley's story is one of power, change, and ongoing risk. The past shapes how we read today's signals. Every tremor is measured against this ancient legacy. The caldera's history is a warning and a guide. We study the past to protect the future. The Earth remembers, and so must we. Monitoring Long Valley requires a network of instruments. Satellites for the big picture, ground sensors for the details. Seismometers detect earthquakes, even tiny ones that hint at magma movement or rock fracturing. Changes in earthquake patterns can be early warning signs. GPS stations fixed to the ground measure surface movements down to the millimeter. If magma pushes up, these stations detect the subtle uplift. Scientists also monitor volcanic gases, sulfur dioxide, carbon dioxide, released from fumaroles and vents. Shifts in gas emissions can signal magma rising closer to the surface. Thermal cameras on the ground or in the air spot changes in ground temperature. Another clue: water chemistry in hot springs and wells is checked for signs of new volcanic fluids. All this data flows into volcano observatories, analyzed in real time, 24/7. No single instrument tells the whole story. It's the combination that matters. Radar from satellites complements GPS. Seismic data helps interpret deformation. Gas measurements confirm what sensors suggest. This vigilant watch is a continuous effort, involving dedicated scientists and technicians. They are the guardians, using technology to listen to the volcano's heartbeat. Their work is vital for timely warnings and community safety. The system is always on alert, ready to detect the slightest change. Every sensor adds a piece to the puzzle. The goal: catch the earliest signs of trouble. Technology and teamwork keep us one step ahead. The volcano is always watched, never ignored. Science is our shield against the unknown. The network is strong, and so is our resolve. Long Valley's secrets are under constant surveillance. The data from Long Valley is massive. Satellites, seismometers, GPS, gas sensors, all streaming information non-stop. Humans can't process it all fast enough. Enter artificial intelligence. AI sifts through huge datasets, spotting patterns and anomalies that humans might miss. It acts as a powerful assistant, filtering out noise and highlighting signals that matter. Machine learning models, trained on past volcanic crises, flag warning signs for experts to investigate. This speeds up analysis and improves forecasting. Volcanic eruptions are complex, but AI can incorporate more variables and adapt as new data arrives. AI won't replace human volcanologists, their expertise is irreplaceable. Instead, AI enhances their capabilities, offering earlier warnings and more reliable forecasts. The use of AI in volcano monitoring is growing fast. It helps us decode the volcano's subtle whispers with speed and precision. This technological leap is crucial for living with active volcanic systems. AI and science together make us better prepared. The future of volcano monitoring is smarter and safer. Magma is moving beneath Long Valley, but what does it mean? Magma movement is common in active volcanic systems. Most of the time, it doesn't lead to eruption. The current news is significant, but not an immediate cause for alarm. Scientists stress, an eruption is not necessarily imminent. The detected movement is a reminder that the volcano is active, not a sign of impending disaster. Scientists look for a cascade of signals: accelerating ground deformation, increasing shallow earthquakes, major gas changes. The key is to monitor trends closely and interpret them in context. Magma at great depth is less concerning than magma rising toward the surface. It's a waiting game, careful observation and interpretation. The Earth is sending messages. Scientists are working to decode them. Public communication is vital awareness, not panic. The message is clear: be prepared, stay informed. The volcano is reminding us it's there, and we're listening. Long Valley isn't California's only volcanic concern. The state is geologically active, with several volcanic areas. From Mount Shasta and Lassen Peak in the north to the Salton Buttes in the south, each has unique hazards. The recent activity at Long Valley is a reminder. California is volcano country. The USGS monitors all potentially active volcanoes with networks tailored to each threat level. Mount Shasta and the Salton Buttes are closely watched due to their history and proximity to people. The news from Long Valley elevates focus statewide, prompting reflection on preparedness. Are emergency plans up to date? Are communities aware of the risks? Volcanic eruptions, though rare, can have devastating consequences: ashfall, lahars, and more. Understanding these hazards is the first step to reducing their impact. California's volcanic pulse is part of a larger geological story. Ongoing research, robust monitoring, and public education are essential. Living with volcanoes means respecting their power and being ready. Detecting magma movement is one thing. Being ready for an eruption is another. California agencies with the USGS develop emergency plans for volcanic scenarios. These plans outline evacuation routes, shelters, and public warning systems. Preparedness is a continuous process, updated as new science emerges. Public awareness is crucial. People need to know what to do, from ashfall protection to emergency kits. Community meetings, drills, and educational materials empower residents. Even a moderate eruption could disrupt air travel, water supplies, and agriculture. Preparedness involves coordination across many sectors. The interconnectedness of society means volcanic events can have far-reaching effects. The recent activity at Long Valley is a real-world reminder to review and reinforce plans. The time to prepare is now, not during a crisis. Investing in preparedness builds resilience. Proactive planning is our best defense against volcanic hazards. The story of Long Valley is about more than geology. It's about resilience, science, and community. When nature's power looms, people come together: scientists, emergency managers, and community leaders. Technology extends our senses, but it's human expertise and clear communication that turn knowledge into action. Public education is the cornerstone. Understanding volcanoes replaces fear with awareness. Informed citizens are empowered to act and stay safe. Education should be ongoing and accessible to all. An educated public is a prepared public. The recent magma movement is a call to vigilance and an opportunity to strengthen preparedness. It's a reminder of our dynamic planet and our ability to adapt. Hope lies in science, planning, and community spirit. By working together and staying informed, we can face the future with confidence. The Earth's challenges are great, but so is our resolve. Together we are ready for whatever comes next.